Hello everyone. Today we will talk about some initialization things, constructor calls, and how we can delete the copy and assignment operators, copy constructors and assignment operators with the new C++14 compiler. So let's start with the constructor calls. Suppose I'm writing a class here. This is a dummy class, and then I'm going to write two variables. And here I'm going to write two constructors for it. Underscore b, and at the same time I'm writing one more constructor, which is a one argument constructor. Okay, so this is my old version of compiler. I'm passing the b underscore b to the one argument constructor. Let's see what happens. This is the old version of the compiler. So I think you know what will happen. It will not let me compile this program. Let's compile it and let's see what happens. Okay, so it shows you that illegal member initialization. Dummy is not a base or member. Basically, in older versions of the compilers, you can only call the base version of the constructor, not the constructor of your own class. I mean, constructor within a constructor cannot be called for the same class, right? But let's see what happens if we do this here. And let's compile it. This is an online compiler, which is jdoodle.com. From jdoodle I have opened it. So there was one more earlier in my earlier video. It was online GDB, but I have used the other one today. So let us compile and let's see what is the result. See here, no problems. It is not showing any output because I have not written anything in main function, but it didn't give me any compiler error. So it is perfectly fine with the C++14 compiler, right? So in the most earlier versions of the C++, you can have a call of constructor within the constructor, but it will not initialize the variables. I mean, if you have called this in the older version, the oldest version, this was applicable in some of the earlier versions where you cannot call it like this, but you could have called it like this. This was in the most earlier versions of the C++. But what happens that here, if you see this line, you can see that this line is telling you that I'm going to create an unnamed object which will be destroyed as soon as I reach to the next line. Means as soon as this line will be executed, this object will be destroyed. So if we expect from the older version that this dummy b will initialize with the value of b whatever we have provided, then it will not happen. It will only initialize the value of a or whatever you have provided correctly, not through this call, not through the constructor inside constructor call, right? So let's see what happens now with C++14 compiler. So let's see, this to a is equal to underscore a, and here this to b is equal to underscore b. Now let's see what happens. Dummy d, I'm passing 12 and 13, and let's see what happens. Out we can write a function here, void show, and it will display both the values. So I will call d.show. You can see here both have been initialized perfectly fine, 12 and 13. So with C++14 you can have a call of constructor within another constructor in the same class, but in earlier versions it was not allowed, right? Okay, so this was about the constructor inside constructor thing. Now I will talk about something, the initializations. In earlier versions, if I see initialize an array using this 3, 4 and 5, it compiles, it doesn't give me any error. Right, so this is fine. If I do like 5.9 here, means it's an integer array, but still I'm providing a floating value, a double value, then also it will compile with an error, with an warning, with a warning. It gives me a warning that conversion from double to int is going to be performed, but it succeeds. It doesn't give you an error, it doesn't stop you to run your program, right? But let's see what happens with C++14. Let's do this. Let's see what happens. See, you can see that narrowing conversion of this from double to int inside this, and it's an error here. So in C++14, the same action will cause an error, right? But in C, older version of C++, it is perfectly fine. It will give a warning, but it will not stop you to run your program, right? Now one more thing, which is available in C++14 but not in C++ older versions. You can notice that I have just removed the equal sign from here, and I have just provided this A5, and then in the curly braces I have provided the values. Okay, so there is no error, and let's see what happens. For auto, I'm using the new version of for loop here, and let's see if it prints or not. If it prints, then we are sure that yes, it was perfectly initialized. So here you go. You can see that 1, 2, 3, 4, 5, everything has been printed here. So it's fine. But can we do the same thing in older versions? I'm sure you know that the question is no. We can't do. It is not allowed in older versions of C++. But in new version of C++14, it's available. You can do the same thing. See here, you can see 1 failed, 0 succeeds. There are 2 errors, right? So this is not allowed. Okay. And in this new version, we can also see that this thing is also allowed with the other container types, like we have STLs as well. So we will see an example with vector as well. Vector int v, and here I'm going to put it 5 and 2, right? So it will compile, and if I do for auto a v, and it will work. It will show you 5 and 2. Okay, but the same thing cannot be done in C++ older versions. Okay, if you will try the same code in C++ older versions, it will not work. But with new version, C++ 14, it will work. Okay, let's do one more thing. Instead of curly braces, can I do this thing? What will be the output? See, this is a constructor call. The first argument is the space reserved for the number of integers, and the second one is the initialization value with which I will initialize that space. So there will be 5 integers and each of them initialized with 2. Let's see. Here you can see this thing, 5 2's. So you need to be very careful when you are using these curly braces things, right? So if you are using curly braces, then only you are initializing, otherwise no. Okay, now it's 5 and 2, right? Not even this, you can do other variations like v dot insert, v dot end. At the end, I want to insert few more values, 34, 45. And if you run this and you trade this, you can see that 5 to 34, 45, everything has been printed here. So this makes the things more versatile, right? So the things have become more versatile with these initialization things introduced in C++ 14, right? So this was about the vector initialization and other initialization lists. And the other thing which remains for today is copy constructor and assignment operator deletion, right? So I will give you an example with the unique pointer. This is my older version of the compiler, and hence in this compiler the unique PTR will not work, right? Unique PTR will not work here because the older version of compiler doesn't know about the unique PTR. It knows about auto underscore PTR but not about the unique underscore PTR. So let's see what we will do. So use the unique underscore PTR. We need to include the header memory, hash include memory, and now we will do here unique underscore PTR. I will store integers here, p key. Not p, let me make it up, unique PTR, and here I'm going to add a pointer of integer type. You can write p here. And if I write asterisk p, then it will be printed here. The value of 10 will be printed here. Sorry, asterisk up. Okay, so you can see that I've used the unique PTR. It's a smart pointer. And instead of integer, you can have your own user-defined types as well. If you have studied about unique PTR, then it's okay. You might be aware about that. But if you are not aware, then just remember that it's a smart pointer. And whatever kind of type you provide here, you can provide a pointer to that type in the initialization list, in the initialization, in the constructor of this unique PTR, right? So there is one more feature of a unique PTR, that if I do like this, unique underscore PTR int, and if I write up1, and then if I try to do this up, if I try to create a copy of this unique PTR, then it will not allow me to do so. You can see that it's showing me an error, that the function, this unique PTR, this reference, sorry, not reference, the copy constructor is not available here, right? So you cannot use this. Similarly, if I do up1 and then up1 is equal to up, If I try it through the assignment operator, then also it will not allow me. Okay, so it says that use of deleted function this. It means the assignment operator has also been deleted from the unique PTR class. So this is the new feature which has been provided by the C++14. In case of unique PTR, you cannot transfer the responsibility this way. You cannot transfer the ownership of one unique PTR to the other unique PTR using the assignment operator or the copy constructor, right? But this was possible with auto PTRs. If you know about the auto PTR and unique PTR, then you might be understanding this. But my main purpose is to show you that how these copy constructors and assignment operators can be deleted in your own class, right? So we will be writing our own unique PTR class to make it more clear. So let's remove all this. Let's remove this memory as well, and we will create our own class. Underscore unique PTR, and here private underscore ty asterisk p, and then public, and I write here unique explicit underscore unique PTR, and here I would accept this underscore p, and what I will do here, I will just assign this p to underscore this underscore p to p, and this is underscore p, right? And then since it's a smart pointer, then we need to expose two more overloaded operators. One is ty asterisk operator. Which operator? This one. What it will return? P. And one more operator is needed, which is the asterisk operator. It will return a reference. Okay, so we will use the same code with our unique PTR. I have written UP, and I will provide P here. Right? If I write like this, asterisk P, asterisk UP, then it will give me the same result as the original unique PTR was giving me. Right, you can see that it's saying me something unique underscore PTR. Sorry, here I just forgot to provide the type. Okay, so now you can see the output is 10, and let's do the same thing what we did with the original the provided version of unique PTR. I mean, I will try to copy it. P1 UP. It will not give me any error because the copy constructor is by default provided by the compiler, right? And I have not stopped it, right? Similarly, if I do up1 is equal to up, then also it will allow me to do the same thing. It will not stop me. Okay, why it is giving me the error? Because I have not provided a zero argument constructor here. So I will provide a zero argument constructor here as well. So it will allow me to just create a 0 argument constructor variable. So it allowed me, but in the original version of C++ 14, the unique PTR provided in the library is not allowing me to copy or to assign. So how we can stop that? So to stop that, the keyword is delete. If you have to stop that, if you want to stop that, if you want to stop that the copy and the assignment should not be allowed, then in that case you need to do this. This is your reference. You just need to say delete, and for the same at the same time you also need to do unique underscore PTR and operator equal to underscore unique PTR and reference is equal to delete. Now we have told the compiler that we don't need this copy constructor and assignment operator in this class, so that no one could be accidentally able to copy the object or assign the object to some other object of the same type. Right, so now my program will not compile because I have deleted the assignment operator, the default assignment operator. See, you can see the same error that we used to see with the original version of the unique underscore PTR. This was assignment operator, and if I do the same thing for copy constructor, then also you will not be able to compile it. Right, you can see the error here, right? But please note that you cannot write this program in old version of C++. I mean, this thing equal to delete for assignment operator and copy constructor is not allowed in older version of C++. Okay, so now you have understood three things today. One is constructor calls within the other constructor, from the other constructor, then the initialization rules, and then how to delete copy constructor and assignment operators in the new version of C++ 14. Okay, that's it for today. Bye.